Howdy Pre-Cal, it is Miss Kosh, and in today's video I am trying a slightly new approach to teaching the unit circle. So it might be exactly what I've done in my previous videos, but I have a new document that I'm basing things off of. Okay, so here we go. We're going to start with, we call this the unit circle because the radius is 1 unit. So, in other words, r is equal to 1. And so when we start finding we can find coordinates on this circle, we're going to assume that it's centered at the origin. And so this point over here has gone 1 unit in the x direction and 0 units in the y direction. This point over here has gone 0 units in the x direction, 1 unit in the y direction. This has gone -1 in the x, and there's 0. So we're assuming, we don't have to label this, but we're assuming that we're sitting here at 0, 0. I'm going to take that off so that we're not tempted to write that because it's not a point on the circle, it's the center. And then this one, we've gone 0 units in the x direction and -1 in the y. Now you hopefully remember that this is 0 radians. That was our initial side, always starts on this positive x-axis, and so it's 0 radians. And then if I take my whole 2 pi, we've talked about this a few times, so I'm going to go a little faster. So if I take that 2 pi and divide it into 4 chunks, each chunk is pi over 2. So this up here becomes pi over 2. This one over here is 2 pi over 2, which reduces to 1 pi. Down here, we're at 3 pi over 2. And then we also get back, and this could also be labeled as 4 pi over 2, which reduces to 2 pi. Now, when I make you fill out the unit circle, you can give me 0 or 2 pi. You don't have to give me both. That's just my preference. The other thing is this is also 0 degrees. But when I have you fill out the unit circle, sometimes we like to race in my class, and so that degree symbol just starts to get sloppy, so we'll just leave it off. But if I take 360 degrees and divide it into 4 chunks, each chunk is 90 degrees, and so this becomes 90. This, hopefully you see, is 180. Over here we're at 270. And here we get back to 360. Same idea. You can, if you just give me 0 and 0, that's fine. You could also give me 2 pi. You can also give me 360, but in my world, you don't have to do both. Okay, so now that was these values here. We now have the, we had talked before about the radian measures of all those, so the part in red. But what we now have is the degrees should make sense. That's kind of obvious to us. But we now have coordinates. Okay, so let's look at this next one. So in the next one here, we're at the pi over 4 family. So this is 1 pi over 4. Then 2 pi over 4 would be here, but I'm not labeling it on purpose because it's in the pi over 2 family. So then here comes 3 pi over 4. 4 pi over 4 would be here, but we've already got it. It's in the pi family. And then here comes after 4 comes 5 pi over 4. The 6 pi over 4 would be here, but I'm not labeling it because we already did it. And then this becomes 7 pi over 4. So with each of these are the 4 angles in our first rotation around the circle between 0 and 2 pi that are in the pi over 4 family. Now everything that we're saying for these holds true for all coterminal angles. So if it is anything that's coterminal to one of these 4, it's going to also work. So what we know is that we have a circle with a radius of 1. So what I'm going to do is I'm going to look at this. Well, if this angle is pi over 4, we know that it's a 45-degree angle. And here's that 90 when we drop this in, and so here's another, it's a 45, 45, 90 triangle. We said the radius is 1. That means this whole thing here is 1, but that's not very helpful. But this is also a radius, how it goes from the center of the circle to this point out here. That radius is 1. Now, if we want to find the coordinates of this point, though, here is the x value and here is the y value. And so let's use what we know of 45, 45, 90 triangles to find those lengths, okay? So hopefully you remember 45, 45, 90, we write x, x, x root 2. What they gave us is that they gave us that is equal to 1. And I also hope you remember, do you remember the very first day we looked at right triangles? There were 2 problems, and I was like, star this. This is going to be important. This is going to come back. This is one of those problems. Let me finish it and then I'll show you what I'm talking about. Okay, so this says x root 2 equals 1. We're going to divide both sides by root 2. And then I'm going to multiply by what I call a funky form of 1. This is a funky form of 1. And so I can always multiply by 1 and nothing changes. What happens here is that x will now equal root 2 over square root of 2 times the square root of 2 is 2. And so both of these are root 2 over 2. So this tells me this length here is root 2 over 2. It tells me this length is root 2 over 2. And so the coordinates of this point right here, that pi over 4 is kind of in our way, but the coordinates, the x coordinate is a positive root 2 over 2. The y coordinate is a positive root 2 over 2. Okay, so now let's think about this for a second. What we're going to do is we're going to reflect this into quadrant 2. So this point here now goes, it's reflected over the y-axis right here. And now we have the, so we have the same, this length right here is the same as this length right here. Okay, I don't want the clutter in my work, but this point now has an x-coordinate of negative root 2 over 2, because we've gone in the negative direction, and a positive root 2 over 2 in the y direction. Okay, now I can reflect again, and I can reflect again, take that point and reflect it into quadrant 3, go from quadrant 2 to quadrant 3 by reflecting over the x-axis. And I have, notice, if I were to draw this triangle, this length right here is the exact same. And it's the same as this, and so this is a negative root 2 over 2 in the x direction. And hopefully, I want to erase this other stuff. I want to get rid of this clutter. And a negative root 2 over 2 in the y direction. Okay, now we can reflect, either we can think of reflecting from quadrant 1 into quadrant 4 or quadrant 3 into quadrant 4. Either way you do it will work. This point right here has the coordinates. It's now a positive x value, positive root 2 over 2, and a negative square root of 2 over 2, a negative y value. Okay, and so this is what we need. So now we've got our coordinates for the pi over 4 family. Oh, I should probably do degrees. So this was still 0 degrees. Let's take, if we take this 360 and we divide it into the 8 chunks that we have, sorry, still fighting a little congestion. Each one is 45 degrees. So this angle up here is a 45 degree. Here comes 90, which we don't need to write down. And 90 plus 45 is 135. Add 90, excuse me, I lied. Add 45, we're at 180, but we don't need to write that because we already know it. Oh, we do need that. Add 45 to that gives us 225. Add 45, we're at 270, but I don't want to write it down because it's in a different family. Add 45 to 270, and I'm at 315. Add 45, and I'm back to 360. So here are the degree measures, the radian measures, and the coordinates for the pi over 4 family. Super. Okay, we've got 2 more families to look at. The next one, hang on, I need some water. Okay, let's see if I can not cough. That would be the goal. The next one is the pi over 6 family. So if you remember, when I took that 2 pi and I divided it into 12 chunks, now you don't see all 12 chunks because there should be a chunk here and here and here and here. But those 4 that I just drew are the pi over 3 family, and so we're going to save those for a minute. Okay, so each one of those chunks is pi over 6. So here's 1 pi over 6. And now when we are pi over 6 less than pi, this is 5 pi over 6. When we're pi over 6 more than pi, we are at 7 pi over 6. When we're pi over 6 less than 2 pi, we are at 11 pi over 6. And we did talk about this before when we divided it into 12 chunks and we wrote all those different fractions and simplified. But now I just want to focus. Am I doing the same colors that I did before? Nope, I got off with my color scheme. Well, sorry, here we go. And so then let's also look at our angles. Those are angles. Let's look at them in radians. If I take 360 and divide it into 12 chunks, each chunk is 30. So we're at 30. We're at 30 less than 180, which is 150. We're at 30 more than 180, which is 210. And we're at 30 less than 360, which is 330. Okay, so here we have measured our angles in the pi over 6 family. And now we need the coordinates. Okay, so this is clutter. Actually, I'll just move this out of the way. There we go. Okay, so now we are looking at this lovely triangle. We're trying to find the x-coordinate here and the y-coordinate here. And we know that this is a 30, 60, 90 triangle. And we know this is the what circle? Hopefully you answered that question. It's a unit circle. It's the unit circle because the radius is 1 unit. Here's the radius in this triangle. So now, off to the side, I'm going to write down 30, 60, 90. I have x root 3, 2x. And I have the piece opposite the 90 is 2x. So if 2x equals 1, then x would equal 1/2. And the next one, it's 1/2 times root 3. So you could say that as 1/2 times root 3, but that's just a whole lot of writing. The more efficient way to say this is root 3 over 2. I multiply the numerators with the numerators and the denominators with the denominators. And that is quicker to write. Okay, so now let's find that coordinate. This is, hang on, so sorry. Opposite the 30 we said was 1/2. Opposite the 60 we said was root 3 over 2. And so now this coordinate up here, I didn't save myself space, this is the point. Our x-coordinate is root 3 over 2. Our y-coordinate is 1/2. And now we're going to take this and we're going to reflect, reflect, reflect. So when I reflect it over into quadrant 2, I still have an x-coordinate of root 3 over 2, but now we have gone in the negative direction. So that's a negative root 3 over 2. The y value is still positive, and it's still a positive 1/2. Okay, down over here, we're in the quadrant where both x and y are negative. And so that is a negative root 3 over 2, a negative 1/2. And then we reflect, that was this point. Now we reflect into quadrant 4. The x-coordinate is positive, and the y-coordinate is negative. So maybe I should have said this at the beginning, but just a reminder. In quadrant 1, both x and y are positive. In quadrant 2, the x value is negative, but the y value is positive. In quadrant 3, they're both negative. And in quadrant 4, the x is positive, but the y is negative. That's going to happen all the time, every time. Don't mess that up. Get that right. Okay, so that was the pi over 3 family. I lied. That was the pi over 6 family. Now let's look at the pi over 3 family. So thinking, let's coordinate what colors I did before. Okay, so this is 1 pi over 3. This is 2 pi over 3. 3 pi over 3 is actually here. That's pi, but we don't want to write that down because we already have it. So then this becomes 4 pi over 3, and this is 5 pi over 3. Okay, when it comes to degrees, if I take, well, so this was, remember how we had that pi over 6? That's not quite the right place. But the pi over 6 was 30 plus another 30. This is going to put us at 60 degrees. This would put us, 60 beyond that is 120. 60 beyond that is 180 right here, but we don't want it. 60 beyond 180 is 240. 60 beyond that is 300. And 60 beyond that, but we get back to 360. So there are the degrees and the radians for the pi over 3 family. Okay, so now back to our lovely little triangles. Pi over 3, we just said, is a 60-degree angle, which means that here is our 30, 60, 90, 30, 60, 90, x root 3, 2x. And we know it's called the what circle? I couldn't hear you. Okay, I'm kidding. It's called the unit circle. So this across from the 90 is 1. So if 2x equals 1, x equals 1/2. Oh, we've seen these numbers. 1/2 and then root 3 over 2. But now opposite the 30 is down here, and opposite the 60 is over here. Okay, so what are the coordinates of this point? Well, I didn't save myself space. It's a positive x of 1/2, a positive y of root 3 over 2. Here we are. This is now a negative 1/2 because the x value is negative, and a positive root 3 over 2 for this point right there. This one is going to be negative, negative. So a negative 1/2 and a negative root 3 over 2. And now we're here. The x-coordinate is a positive 1/2 because the x-coordinate is positive in quadrant 4. And the y-coordinate is negative, a negative root 3 over 2. Okay, that is the unit circle. But we just broke it apart into pieces. So here's what I'm going to ask you to do. I'm going to ask you to put it all onto one circle. And then I'm going to work this one with you. And then your homework is to do, the daily grade. How do I want to do this? I'll give you 20 points apiece for the first 5 up to 100, and then 10 points apiece beyond that. And I'll cap it at, it's going to average in with other things. You know what? Let's see. If you do, what is it, 5 for 20 points, that gets you 100. If you do 10 more, you know what? If you did 10 more beyond that at 10 points each, I'd cap you at, that would give you another 100 points. I'd cap you at a 200. So if you want, I'm not supposed to give you bonus. Don't tell anybody. And here I am putting it on the internet for everybody to hear. But if you did a 15 unit circles and on paper, because it's too easy to copy and paste on your iPad, and you can change the color and act like, oh, look, I did it again, and you really didn't. If you do it 15 times on paper and you show me that, I'll give you a 200 points out of 100, and that will average in and really boost your daily grade. Yes, you're welcome. I want you to grind this out in practice. Okay, so I will count one of them you do on your iPad because you can't copy that one. And then after that, you have to do it by hand. Okay, so let me show you. So we're going to put everything together. One way, when I do this, you may notice I have a video where I'm racing another teacher because I like to race my classes, and I'm going to make you fill it out. I'm going to make you do a blank one, but if you can do it faster than me, I'll give you bonus points. Enough to make it worth your while, but I'm good. So when I do this unit circle, I go around the circle 3 times. I go around once doing degrees, I go around a second time doing radians, and I go around a third time doing the coordinates. I don't know that that's the best way to get you to start. So what I would suggest you do is think in terms of, let's do radians first, because that can be a little tricky. And we'll start, so we know that this is 0 radians, we know that this is pi radians, we know that this is pi over 2, and this is 3 pi over 2. Okay, and then we can do the pi over 4 family. Well, the pi over 4 family is between the, it's in the middle of each one of those. So that's 1 pi over 2, 1 pi over 4, 3 pi over 4, 1, 3, 5, and 7 pi over 4 go in those places. Now we can do the pi over 6 family. That's the one that's closer to the x-axis. So that's 1 pi over 6. Here comes 5 pi over 6. This one is 7 pi over 6. This one is 11 pi over 6. And the family that we haven't written down is the pi over 3 family. So this is 1 pi over 3. This is 2 pi over 3. 3 pi over 3 would also be x. I wrote those, everybody else. You know what? Here, let's just clean this up a tiny bit. Let's move you to the outside, and we'll solve this. We'll deal with our problems later. Oh, okay. And so we had, this would be 3 pi over 3 over here, which we already have. So this one is 4 pi over 3. And here comes 5 pi over 3. And now I have labeled everything in radians. Okay, so far so good. There's more. Now let's look at degrees. So I would do another 0 here. So sometimes I'll do it this way. I'll just do 0, 0, because it's 0 degrees and it's 0 radians. And then as far as degrees go, we can go 30, 60, 90, 120, 150, 180. You'll notice I'm adding 30 each time, 210, 240, 270, 300, 330. So I did the pi over 2 pi family and also the pi over 3 and the pi over 6 family all at the same time because I was just adding 30. Now all I have to do is do the pi over 4 family, which is 45, 135. All of a sudden my brain stopped. 180 plus 45 is 225. Well, and notice it's 15 away from each of those. So that number looks terrible. Let's fix that. This is a 240. Okay, so you would add 15, so 210 plus 15 and 225 plus 15, and then you have to add 30 to keep going. And then this one is 315. Oh, I'm on the eraser. Okay, so we've got the degrees and the radians all the way around our circle. There's absolutely nothing wrong with doing it the way that I'm doing it right now. When I do this myself, I tend to just do one solid circle. I'll just go 0, pi over 6, pi over 4, pi over 3, 2 pi over 3, 2 pi over 2, 2 pi over 3, 3 pi over 4. Anyway, we don't need to hear me say all this. Okay, so now we're looking at coordinates. Now, when I think about the coordinates, here's how I put these in. I think about the numbers I care about. I have a 0 I care about, I have a 1/2 I care about, I have a root 3 over 2, I have a root 2 over 2, and I have a 1, and I have all those in positive and negative. So what I actually want to do is put them in order from smallest to largest, and I need to actually switch these two. And now, so you can think of this as 0, 1, 2, 3, and then, so if we think of this as being 0 over 2, 1, the square root of 1 over 2, the square root of 2 over 2, and the square root of 3 over 2, and the square root of 4 over 2. Notice square root of 1 is 1, and so we don't really need this part right here because that's the same. And then the square root of 4 is 2, so 2 divided by 2 is also 1. So we can just kind of put these in order and think of what's going to be smallest to largest. Okay, so if we put them in order, this is smaller than that, it's smaller than that, it's smaller than that. It's going to make our life easier. So this coordinate is, I need more space. Okay, this is the point 1, 0. And now right here, the next largest number after 1 is root 3 over 2. Not root 3, it's root 3 over 2. So this is root 3 over 2, comma 1/2, because those two are buddies. And then this one is root 2 over 2, comma root 2 over 2, because those two are buddies. And now this one is getting a little smaller. This is 1/2, comma root 3 over 2. And now I've gotten to here where my x value is 0, my y value is 1. Okay, so now we're going to go on the other side. Well, the smaller x value, the smallest of the x values is 1/2, but this is now in the negative direction. And it travels with root 3 over 2. And then I have the next smallest is negative root 2 over 2, comma positive root 2 over 2. And then here we have a negative root 3 over 2 and a positive 1/2. And now we're here at this one where our x value is negative 1 and our y value is 0. Okay, continuing on. We're kind of going, so we went from the largest, our x value went from the largest to the smallest, and then we got to the next quadrant, we went to the smallest to the largest, and now we're back in a quadrant where we have to go, as you move around, we're going to go get smaller. So negative root 3 over 2 travels with negative 1/2, but this one's negative. A negative root 2 over 2, and this is a negative root 2 over 2. Because in this quadrant, x and y are both negative. Now this is negative 1/2, which is the one that's the closest to 0, and then a negative root 3 over 2. And this is 0, negative 1. This one becomes, I'll write it down here, positive 1/2 and a negative root 3 over 2, a positive root 2 over 2 and a negative root 2 over 2, and then a positive root 3 over 2 and a negative 1/2. Oh, I did kind of. Okay, so when I have you write this, I want to see, it needs to be clear what you're labeling. Okay, so you can, sometimes I write them on the outside like this and kind of have them in a line. Sometimes I put them on the inside, but this is kind of obviously going to that point right here, etc. And that's the unit circle. And next time, we are going to talk about why we care. But in the meantime, I want you to practice, and I'm gonna have paper for you. And actually, I'll put this blank copy on in the description of this video down below. So if whoever you are, if you're watching me somewhere around the world, you can print this out and practice, and just write really small and grind it out and practice it and practice it and practice it and practice it and practice it. But I do think remembering that this is the order of our numbers really helps. Okay, so you want to think, am I going farther out, or am I closer into 0, or am I farther away from 0? And kind of keep those in order. All right, like, subscribe, comment, and go practice. And I really do. My kids, I'm expecting to see a ton of unit circles done when I see you. Okay, go work. Good luck.